enough. This is a really important thing. This is something about computing that affects their lives directly. This is one of the most exciting bits of this. Getting the cat to move across the screen, doing little cartoons there, creating games. Yes, that's great fun. Keep doing that. But getting children thinking about what they can do with data, about how their data is being used, I think is tremendously important. This is part of our computing curriculum. If you're working with 5 to 7-year-olds, who are those of you working with 5 to 7-year-olds? It's great fun, isn't it? Recognise common uses of IT beyond school? Big data is a very, very common use of IT beyond school. And I think our 5 to 7-year-olds ought to know something about when they borrow a book from the library. There's a record of that. When their parents are driving along, there's a record of that being made, making them aware of how much data they are generating. 7 to 11-year-olds. This whole train wreck of drafting there in the national curriculum. Select, use, combine a variety of software, including internet services, on a range of digital devices to do lots of things, including, given goals, collecting, analysing, evaluating, and presenting data. It says data and information in the text there. But there's an explicit reference to collecting, analysing, evaluating, presenting data. And I worry from the students I go and see in school, from the stories I hear, that we focus so much on programming that we're missing out some of the really important bits of the curriculum that come later. 11 to 14-year-olds, design, use, evaluate computational abstractions, modelling the state and behaviour of real-world problems and physical systems. This idea of modelling something, really interesting way of getting into probability, getting into data there for the 11 to 14-year-olds. Creative projects that involve selecting, using, combining multiple applications, range of devices, challenging goals, including, yes, collecting and analysing data. There's a sense in which Key Stage 2 is more ambitious than Key Stage 3. Statutory curriculum for Key Stage 4. Yes, there's this thing in the national curriculum about all pupils should have the opportunity to study, but then there's also bullet points about what everybody should be taught. And I think we're conscious that as our friends at Ofsted, that normally gets a cheer. Never mind. Our friends at Ofsted are coming in and looking at this sort of deep dive, breadth of the curriculum. Are you teaching something at least as broad as the national curriculum? That stuff which is there in everybody should be taught in Key Stage 4 is something they will look at. And that includes develop and apply their analytic problem solving, design and computational thinking skills. And the analytic bit allows us, I think, to do some really interesting data science stuff up in Key Stage 4. Big data projects in the A-level, in the GCSE, can't remember. I think it's the A-level. So yeah, you've got all of that there as part of the national curriculum. You've also got stuff about privacy. Key Stage 1, children should be taught to keep their personal information private. We know that when that was drafted, it was about not letting creepy people on the internet know about you. But their personal information includes an awful lot more than that. My search history is relatively personal information. I'm not going to put that on the big screen at the front of the room now. Shouldn't have mentioned that with the recording going, yeah? So, that's something which is really personal information. Who is it who's got hold of that? Well, Google have to know my search history. How else does it work? Making sure that even Key Stage 1 know every time they go to a website, every time they do an internet search, there is a record of that. Too scary for little ones? No, it's part of their world, isn't it? Make the choices. You also got that in Key Stage 3 about keeping information private. Key Stage 4 has this learn about new ways to keep personal information private. I'm not quite sure what's meant there. Is it Tor and VPNs? Could be. Right. When we drafted the national curriculum, we had this lovely model of there are 3 layers to this. There's the foundations, the fundamental computer science, the principles, the programming, the Boolean logic, the binary arithmetic. Yay! We've also got the IT layer, the applications of this, getting useful things done with computers. Just because we added in that whole computer science layer doesn't mean to say that the IT layer disappeared. Excel is an incredibly useful skill to have. In the world of work, as you will know, you spend more of your time using Excel spreadsheets than you do programming in Scratch, or indeed programming in Python, unless you're a Scratch or a Python developer. Yeah? We have children who are leaving school not being able to work a spreadsheet. And that's a real problem when it comes to the workplace. This is such a fundamental. You know how much you use it in your day-to-day work, and you're not data analysts, you're school teachers. Yeah? Being able to use Excel and use Excel well matters. And we also had that implications layer there, the digital literacy bit, what are the implications for this, for me as a person, for us as a society, the morality and the ethics of this, keeping yourself safe, acting responsibly. So that was the model for the whole computing curriculum. I think we can take that and apply this to the data science strand of this, and you end up with something that looks a bit like this. Yes, they should know something about probability theory. They should know something about proper traditional statistics. What's the difference between statistics and data science? Oh, probably about 10,000 a year or something. That's what it suggests. Okay? There's an applications layer in there about getting useful things done, and some of the time that's going to involve using software, being able to drive Excel, being able to use pivot tables, being able to use filters, being able to choose the right sort of chart. Are there any circumstances in which a pie chart is the right sort of chart? Never ever. Okay, don't let them do pie charts. Really bad idea. But because they're learning how to code, you think pie charts are all right. Pie charts are all right. Yeah, but never in real life. Okay, just say no. Pie chart anecdote coming up in a few slides' time. Right, where do we go with this? So you also, because they get learning how to code elsewhere in the curriculum, they can start writing code which actually collects, analyzes, does things with the data there. More at Key Stage 3, more at Key Stage 4. But if they've learned how to program in Python, that opens up some really nice data analysis, data science, and indeed machine learning, artificial intelligence tools for them. And yeah, the implications, question everything and trust no one. And when has that been more relevant than now, perhaps? Okay, that they should be worried about what's happening with their data. They should think, is it okay for me to tick the box to say it's all right for you to use this information for marketing purposes? How come Google provides all of these services to all of us for free? Well, basically because they're targeting advertising to us. That's okay, it's a price we're paying. So here's the first pie chart. Not strictly speaking a pie chart, it's like some sort of polar area chart. Drawn by, does anybody know who invented the pie chart? Absolutely, thank you very much. You know, famous Victorians and all that. What is Florence Nightingale famous for? Well, the whole sort of solving healthcare in the Crimean War and perfecting how nursing should be done. But also, fellow of the Royal Statistical Society, she made her case by drawing statistical charts. Data visualization was part of what Florence Nightingale did. It's how she convinced people to improve, I don't know, standards of hygiene out there in the Crimea in the 19th century. Not by saying people should be washing their hands, but by giving the chart as to what happened and how many soldiers were actually dying, not because they were killed on the battlefield, but because they were injured and they were taken into really poor hospitals out there in the field and died because of infections which they got in the hospital. So data visualization has a long history. And this is why I get excited about it, because it's a way of using, well, technology in this case, technology in our case too, as a way of making a persuasive argument about things. It's a way of giving the details. We're not doing this well in this country. Hopefully you guys, when you go back into school on Monday, or whenever they allow you back in, things will have improved significantly. Have a look at what they're doing in New Zealand, though. Okay, New Zealand have got this working really, really well. New Zealand have a brilliant data science curriculum. Very, very simple model. PPDAC, I'm not quite sure how we're meant to pronounce that, but start with the problem. Find an interesting thing for them to investigate. I don't know, you might be able to come up with some interesting data things for them to look at over the next few weeks. Plan how you're going to do that. What is it you're going to measure? How are you going to collect in data yourself? Are you going to use data which is available from elsewhere? It's really worth getting them collecting in the data themselves. Collect the data, manage the data, clean the data. So much of this, the time which you spend on these data projects, is because the data itself is messy, and getting them to think about what is good data, what's a tidy format for this. Then we get to do the analysis, sort it, filter it, draw some charts, look for the patterns, look for the relationships. The stuff which I'm doing with our undergraduate students at Roehampton, it's draw a picture and describe what the picture shows. It's in a picture I can see as your approach to this. You can even do it with a pie chart if you absolutely have to. And then draw some conclusions for this and communicate the message of what the data shows. A lovely cycle that we go around for their data detectives thing. At a higher level, the sort of data science bits inside, well, this is the language R, but in Python you would do this as well. you start with getting your data, and then this idea of the tidy data format, that each row of the table represents a single observation of an identifiable case of whatever it is that you're doing there. Transform the data into a way in which you can help analyze it, and then do the visualization. There's going around and doing the visualization really, really important, and this is accessible to everybody despite whatever their mathematical background is. When it comes to creating the model, that relies on a bit higher order mathematics. So your strong mathematicians will be able to do that at secondary school, at GCSE level, I'm sure. But that's where you head next with this, is creating these models. And there's some great tools out there to do that. And then communicating the findings to people. Make a presentation about this. Make an interactive dashboard about this. Make a recording of this. Shown you already how easy it is to do one of these recordings. Okay, shall we do some examples? Let's do some examples now. So the idea of simulating rolling dice. All of you working in primary school, I'm sure, will have had the thing of giving children dice to roll. It keeps them busy for the whole lesson, writing down what number they get on the dice and plotting some lovely bar charts out of it, yeah? Really noisy. You've not tried this? It's worth trying. Okay, really noisy lesson. But we can get the machine to roll the dice for us. So with a little bit of luck, if the magic works here, I get to open up a spreadsheet, which we prepared earlier. Okay, it's looking reasonably good. Can I make this a little bit bigger for you? Maybe. There's probably some sort of zoom setting. It's just loading. There we go, still loading, still loading. So we've got there 100 rolls of a single die. And I could have done that by hand. I could have paid my daughter at 9 years old to go and roll some dice for me. But what I've got is Excel. I've got a formula in here. This is not Excel, it's Google Sheets. Equals rand between 1, 6. So pick a pseudo-random number in the range 1 up to and including 6. Plot that in the table, and then we just take that formula, fill that across the whole of the row there. I'll never do live demos, too many live demos. And then fill that down the rest of the table. And we get 100 rolls of a single die in there. And we can write a command into Excel, a formula into Excel, to say count up how many of these you've got. So I have, for this cell here, count if everything from that 100 cell there, if it matches the number in cell A14, and there are 17 of those. I'm not going to bother to check that. And then we've got a very nice little data visualization where we just plot that as a bar chart there. I don't know, there aren't very many 4s in the table there. Is that significant? Probably not. We can recalculate the thing here, so I can reload the page or I can reset the formula. So there should be a command to do the recalculation. Not going to do that now. But we can change the formula. So rather than rolling a single die, we could have it rolling, I don't know, maybe a die. What about the numbers 1 to 12? So this is a 12-sided dodecahedral die in that cell there. Take that across and fill that down. We should be getting some different numbers here. Okay, I've got to extend my table downwards, 7, 8, 9, 10, 11, and 12. As I'm writing new things into the table, it's extending that as we go. And we've got those. I'd need to muck around with the chart here. Let's see if we can take all of that data, plot that onto the chart. Oops, no. Not quite. Chart. Edit the chart. Okay. And where's my source data? A13 through to B25. That should be right. Oh, but it's the axes which are wrong. So the x-axis here, I'm going to need to edit that. A13 to A25. That should be absolutely right. But it's not showing me the whole of the axis. Never mind. Okay. Do you reckon? No, there's somewhere in there. Anyhow, you can have a look at the numbers there. We've got reasonably even spread throughout all of those numbers there. That was rolling a 12-sided die. Is that the same as rolling a couple of 6-sided die? Again, we can change the formula. So instead of a number between 1 and 12, what I can do here is take a number between 1 and 6 and add on another number in the range 1 to 6. And so this cell here is 2 6-sided die added together. Drag that across the top there, drag that down here, and we find, oh my goodness, suddenly that's changed. And you should know, your pupils should know, that rolling 2 dice and adding them together, I can't get the number 1 from that. There are loads of ways of getting the number 7 of that. A 12, a double 6 is rare, a double 1 is rare. We get to see that immediately if the graph was working properly as the visualization here in Google Sheets. So that's, simulating something. We can do other sorts of things in terms of probability and statistics. You will have done surveys with your class. Who's done an online survey with their class? What did you use for that?
Google Forms.
Google Forms is so easy to use. It is so cool. So let's do a quick demo of Google Forms now. So I go to forms.google.com, wait patiently for the thing to load. There we go. And I can start a new form. So we can do a quick survey here. And what would be more appropriate than COVID-19? Okay, COVID, I'm trying to type 19 readiness. Okay, and we've got some questions that we can put in here. I'm going to do this as a scale question, because I think scale questions are really very useful. So let's have a go for linear scale. Untitled question. My school is fully prepared for dealing with COVID-19. And then we're going to have disagree strongly through to agree strongly. Okay, so we've got one question in there. We can duplicate that question. Let's have a go at duplicating this question. Give me another question which can be answered on that disagree strongly to agree strongly scale, something to do with the virus.
I will not catch the virus.
Oh, very good. I will not catch the virus. That's really... Virus. Good. Okay, one more question. Oh, can I do it? Let me do one. I want to do... No, does anybody else? Okay, go on, your turn.
I'm looking forward to my school being closed.
Oh, yeah. Now, this is going to be different if you ask your pupils as to ask your colleagues, I'm sure. Okay, maybe not. Looking forward to school being closed. Okay, you'll notice I have not asked anybody to type in their name or their email address. Okay, this matters because once you've got their name or email address, you're processing personal data, and the whole weight of the Data Protection Act and GDPR then is on your shoulders or probably your school business manager's shoulders. Yeah. Also, if you're teaching children to keep their personal information private, then asking them for personal information and not really giving them much of an option about this seems to be a little bit hypocritical, doesn't it? You'll also see that I've none of these. I have the ability to make this a required question. I never turn that on because I always want them to recognize that they've got an option of whether they want to answer the question or not. So we've got 5 questions in there. I'm really interested in your answers to those questions. So let's have a go at sending that to you. So we click on the send thing here. I've got a link for this. And as long as you can copy in this link, which I'll read aloud to you now, docs.google.com/form/d/e/1 capital F capital A I P capital. That's not helpful, is it? Okay, so what I'm going to do is copy that link onto my clipboard here and then go over to a URL shortening service, for example, Bitly. If you've got an account on Bitly, you can create your own custom URL for that. So we click on create, and then we have to come up with a thing which nobody else has guessed. So Brighton COVID. I'm hoping nobody's taken that yet. Yes, okay. So the link has been edited. If I have spelt that correctly, which is a very real danger when you're working up on a stage like this, let's just copy that. I think it's copied it to my clipboard already. We're going to go back into the data skills for all thing. I'm going to replace that with that link. So that was bit.ly/Brighton COVID. And if everything is working to plan, you should be able to get on your device to that form and fill in the survey. Has it worked, sir? That's such a relief, it really is. Give you a couple of minutes to answer the questions. Remember, no personal information is being stored. I've got 3 answers already. That's so good. 4. Oh, you wanted the address? Yeah, okay. That's really annoying when people do that, isn't it? bit.ly/Brighton COVID. 12 responses. That's not quite everybody. Oh, 20. How many of you were really annoyed by the spelling mistake? Okay, yeah, address coming back. bit.ly, Brighton COVID. Okay, you can carry on answering the survey questions, but are you as interested as I am as what people have said? I'm really curious about what we've got here. So we move into our data analysis phase at this point, and Google Form does this for you pretty much straight away. Okay, so we've got quite a lot of unpreparedness there. Thank goodness we didn't get the email this morning saying, stop it, just go home, let them work from home, it's be fine. Okay, but you've got one person, that's really very good. I'm not going to ask, remember this was anonymous data, so we don't know who that was. I will not catch the virus. Hey, that's a lot of confidence there, folks. Okay, no, seriously, that's an astonishing result. None of us would have expected a result like that. I really don't think. What you have, of course, is the ability to export these answers as an Excel spreadsheet. So create a new spreadsheet. Go ahead and create that. And this doesn't suddenly reveal your identities. It does give me the timestamps of when you answered the questions there. But what we can see here is the relationships between the two columns of the data. And you would want to go from just the overall aggregate view to, is there a difference? The people who said, my school is, disagreed strongly with my school is fully prepared, are very confident that they're not going to catch the virus, and they're very much looking forward to the school being one person at any rate. So you've got that lovely crosstab analysis. Is there any relationship between your answer to one question and your answer to the other question? I've singled out one individual. I don't know who that is. Neither do you. Well, one of you does. Okay. There are other things we can do as well. So as I say, they're getting quite good at coding, I hope, your pupils are now getting quite good at coding. No, not yet. You'll get there. They'll get there. They may have a number of weeks when they could just play with Scratch at home. You never know. So there are things which you can do with this. So I've got an example here with a little bit of luck of estimating. Oh, I've actually already had that running. So I have got another version of this. Here we go. Let's have a look inside this. So tomorrow is what Americans call 3/14, March the 14th. Uniquely Americans. Everywhere else in the world we do dates in the right order, putting like the day before the month. But the Americans, for some reason, swap those over. And so tomorrow is 3/14, which is, of course, the first 3 digits of pi. And so, it's known as Pi Day. You can't see my code because that's way too small. Let's try that. So what we've got here is picking a random point inside a 360 by 360 dot box on the screen there. We're going to measure the distance of that point from the center of the screen. If the distance of that dot from the center of the screen is less than 180, then we're going to color it in one color. Otherwise, we're going to color it in another color. Okay, I went through that far too quickly. You can get children dropping things onto pieces of paper and measuring how far they're away. Okay, so what we're doing is, what proportion of those dots fall within a certain distance of a certain point? And those of you who've got like GCSE maths, which should be everybody in the room, should know that certain distance from a certain point, that's describing a circle, isn't it? So what's the chance that they fall inside a circle rather than the outside square? It's got to be something to do with the area of the circle. How do you work out the area of a circle? I don't know. I remember something about pi, maybe. So let's get this running and see what happens here. Okay, and we've got 80, 90, 100 dots already. You can just about see what could easily be the spread of an epidemic there. Dots appearing there on the corner of the screen. We can speed this up, thankfully. Scratch is drawing every dot one at a time there. That's 500 dots so far. That's running quite slowly. Let's make it move into turbo mode. I've got 100,000 dots plotted. Okay, this is like watching paint dry, isn't it? But the picture of the circle is emerging there. Any of those dots which are randomly within that range from the middle of the screen, we're colouring in green, otherwise they're colouring them in blue. And then it's pi out of 4 is the probability there. So if you take those number of dots, divide by the number of dots you've got so far, and then times by 4, you get an estimate of pi. And after 500, 600,000 dots, I'm at 3.14 something or other. And with a little bit of luck, it will get slightly more accurate by the time it finishes drawing a million dots. Seriously, I thought I could take longer. Sarah's waving and saying 5 minutes. They're bored, Miles. Right. Do you want me to move on? Move on. Keep it to 5 minutes. Absolutely fine. Okay, right, let's move on in that case. Okay, it will get there in the end. Let me show you this one. This is another one. This is, remember that thing in Key Stage 3 about modelling the state and behaviour of real-world problems? You don't have to move into Python straight away to do that. This is one I wrote a while ago now. This was written July 2014. This is 6 years old, this code. And what we have here is just 10 random dots which are going to move around the screen. When the dots start off, they're all absolutely fine and happy dots. There they go. They're just trundling around their world. There's a 10% chance that when I release the virus, these dots will be infected. So that should be like 1 in 10 gets infected. And then as they bump into one another, there's a 21% chance that they transmit this virus to the person they bump into. Let's see what happens. There's 2 of them. That's worse than average. So as they trundle around the screen, actually that one just got cured. Okay, this one's going to get cured as well. We had 0! Yes, everybody survives in this case. As I say, 6 years ago, I was working on the principle that hospitals would be able to treat people for this. So, when I say this, I don't mean this, obviously. There's nothing sinister going on. So we've got more of those trundling around the screen. They're just going to bump into one another. When they get to hospital, everything is fine, but we'll see how that goes. So you can take what we know about the transmission of COVID and get pupils writing their own. Let's study the spread of an epidemic. If you turn the movement characteristics off, off and then nothing happens. If you slow them down, then obviously it takes longer for the population to get infected. There's a lesson in there, isn't there? Okay, what else do we have? So we've got, the Gapminder data is just gorgeous. This, again, is accessible even in, I shouldn't say even in primary school, I should say in primary school. This is accessible. So this is Hans Rosling in Sweden, has got lots and lots of big data sets. He's got life expectancy and GDP for every country in the world going back like 150 years or something. There we go. That's the current state of play. We have countries which have high per capita income here. What have we got there? Can I hover over that and get some data out? Singapore, very high per capita income. Also very high life expectancy, possibly less good than it was until very recently. Qatar, they're very high income. China, again, quite high per capita income these days, and pretty good life expectancy as well. You'll notice, embarrassingly, the colour coding on the dots here. Most of the bottom quadrant of this, lower income, lower life expectancy, is sub-Saharan Africa. The world is not a perfect place by any means yet. Okay, but if you move the time slider back, though, so that's 2019. 1969, that was a good year, yeah? See, so many of these Asian countries are in exactly the same place that's India in 1970, yeah? Which is as the case is in sub-Saharan Africa now. Okay, so we have, what's the green dot? United States was doing pretty well then, but look at how life expectancy has increased over that time. We can play that forward, track a dot, pick on a dot, and see what happens to it. Yeah? This race upwards and across there as income improves and consequentially life expectancy improves. There are so many different data sets you can play with that. I'm conscious that time is passing. Let me show you some other examples of this. The Google Trends stuff. So Google obviously keep track of everything that you search for. They will not release your search history to other people. They keep that very private. They won't release that search history to advertisers either. That's the crown jewels from Google's point of view. But they will let you see in aggregate what it is that people are searching for. You can look for the global trends on that. And here, on this tab, maybe, there we go. We have, over the last month or so, what people have been searching for. The blue line there is people searching for coronavirus. Interestingly, the gold line is people searching for COVID, the name of the disease rather than the thing that's causing it. Not many people searching for flu at the moment. You know, of the three search terms, there is one that is dominating there. We can move that from a United Kingdom specific setting to let's have the whole of the world there. You would expect to see a similar pattern emerging, I would have thought. Yeah, similar sort of pattern with the worldwide trends for that. Okay, what else was there to show you? So you can get the COVID data from World Health Organization and others. There is a CSV file of that. You can explore that. This is an illustration using a package called Tableau Public, which lets you do really nice drag and drop data visualizations. Just move the things into the area of the chart, say what you would like plotted. It knows about geography, so it can color in countries. It can color in locations. On a map there, you see Italy, you see Iran. This is, as of yesterday, what the data is. United Kingdom, thankfully at the moment, is still vanishingly small. That's not an interactive chart. Anybody got a school weather station? It's worth getting. It really is. You can buy weather stations off Amazon. You know, they'll send you the thing. You've got the data there. You can also get children going outside with wind gauges and anemometers and so on and collecting this data. Once you have that data, you can start plotting some charts of that data. Keep a record of the weather in your school over a period of time. Do you see any noticeable changes? Well, yes, generally the summer is warmer than the winter. What about over a long period of time? Well, it will take a while until you've got as much weather data as Heathrow have got. But this is the weather station data from Heathrow Airport. This is an average over the previous 60 months. So on the chart here, I'm smoothing out all of the annual variation. The summers are warmer than the winters. And so we're looking at a 5-year rolling average of this. And what you see, really worryingly, until 1991, the average of the previous 5 years' monthly maximum temperature never got above 15 degrees. After 1991, that same statistic has never been below 15 degrees. I think there's a persuasive argument there. I think this is something which children can take their coding skills, this was done in Python, and bring that into a geography and bring that into a science lesson and start looking at the data there. Did have this one to show you, but I'm conscious of the pressure of time. So this is, can I find the right tab for this? Monte Carlo, epidemics. Weather data, yeah. So you can also do, the code is here. The code is linked to from the slide deck. I can't show you the graph it's taken to. There it comes. So you've seen these, warming stripes, this visualization. So we color this in according to the average temperature there. And you see at a glance there, this is monthly minimum temperatures. Recent years, this is per year, have been much, much hotter than the first few years that Heathrow Weather Station was tracking that data. Lots and lots of other open sources of data. I go running these days, so Strava, has a record of everywhere I've run. This is a real problem in some parts of the world. So Americans use Strava, and American soldiers use Strava, and American soldiers go out running with their Strava GPS trackers on, and then it turns out there are lots of American soldiers in these particular locations in the Middle East. There are privacy issues with data, there really are. So Strava is allowing us to turn that sort of thing off now. So we've got 4 visualizations there of people with Strava trackers on and different activities. What do you think is happening in this one at the top right? It's going for a run. That's a park run, okay? 2 laps around a local park. What about this one down here? Yeah, that's racing round a lap. That's multiple laps. That's sort of like, speed training. What about this one? GPS error? It's either open water swimming or paddleboarding. I know the person whose data it is. I can't tell you because of GDPR. That's a paddleboarder. This one, though, what on earth?
Playground.
What did you say? Squash spider, yeah, absolutely. This is a football referee. Saturday afternoon, who spends his time refereeing football matches. It's just, he's running the same distance as the folks on the track here, but doing it in a slightly less predictable, more random sort of pattern. And you can get your pupils doing this, yeah? Give them Fitbits, remember the GDPR requirements. Where are they? What are they doing? There's so much data that we can use. Okay, one close to our own hearts. So this graph shows the average Key Stage 2 point score on entry. So this is back when we did point scores. I know it's percentage on age-related expectations and all that now. So when it was point score in Key Stage 2 SATs, average point score on entry to secondary school across the side there, average GCSE results for their top 8 subjects along the side there. Surprisingly enough, schools which have really good entry at the beginning end up with really good GCSE results at the end. Shock horror, yeah? Schools that have low point score on entry typically get low point score on exit. There are exceptions. What about these? These are very mediocre Key Stage 2 average no, actually they're pretty good. Key Stage 2 SAT scores. But they did really well when it came to the Attainment 8 measure. That's a good school, isn't it? This one, not so much, perhaps. This one, not so much, perhaps, yeah? Very mediocre GCSE results considering the calibre of the intake here. There's actually 2 groups in the chart here. There's a big mass down here, and then there's this, long tail up at the top there. This long tail up at the top here, really good Key Stage 2 point score, really good GCSE results. We've got a name for schools like this. Grammar schools. Yeah, okay, this is not fair, is it? They should be doing better, given that they're making people do an exam before they're even allowed into the school. What about the colour coding, though? Colour coding is their most recent Ofsted grade. The blue dots were graded outstanding. The red dots were graded, the significant weakness thing, the bottom category on Ofsted. If you tell me these scores, Key Stage 2 point score and their Attainment 8 measure, 70% of the time I can predict their Ofsted grade. Okay? Or rather, my machine can predict their Ofsted grade. There's a very, very close relationship, or at least there has been in the past. I think this may be changing now. But you can see there, the bands of the colours there. It makes you wonder why they bother coming and visiting if most of the time they're getting it right anyway. The difference is, there's a difference between the green dots and the red dots. It's really hard for my machine to predict the difference, whether you get a 3 or a 4, on the basis of these 2 measures. I think that's because the bottom category, the significant weakness thing, is because something is quite clearly wrong when the inspectors come in to measure, come in to visit. It's not simply that the exam results don't suggest they're performing well. Finally, sorry Sarah, this implication stuff. We need to make them aware. We need to be aware of ourselves, of where all of this data goes, of what rights and responsibilities we have. Your pupils can demand to see their educational record. Has anybody worked in a school ever where their pupils have demanded to see their educational record? Okay, you're not going to tell them that they have this right because it's asking for trouble, but they have a fundamental right, well, not fundamental, enshrined in legislation. The data subject has the right to see the data that's held about them and to have things corrected when it's wrong. Put your hand up, please, if you're working in a local authority-maintained school. Okay, that's good. Right, your pupils' parents also have a right to see your pupils' educational records, yeah? I think that goes down as far as your mark book, but hopefully your school business manager will argue the case if it ever comes to that, yeah? But the child's educational record is something which both the child and the parent have. Those of you who are working in academies, free schools, independent schools, hands up. Your pupils' parents don't have a right to see the child's educational record, which I think is astonishing. I don't think there are any academies, free schools, independent schools which say, no, not going to tell you. I think you would feel obliged, but it's different legislation. The data subject thing is enshrined in law. The other thing about the parents is in regulations, and the regulations didn't ever get applied to the other sorts of schools. It's really weird and inequitable in my view. Don't tell them that. So what else have you got going on there? Oh yeah, anybody using schoolstickers.com? You're possibly using other things. Class Dojo. Class Dojo is really cool, really nice behaviour reinforcement, behaviour management thing. Schoolstickers.com do this lovely thing every Christmas. You know the thing about Santa's making a list, he's checking it once, he's checking it twice, he's probably in breach of the GDPR, but let's not worry about that. So schoolstickers.com, just trawl through their database and see, okay, which children have been given all of the plus points, who are the good children? What are their first names? First name not really personally identifying information. Which children have been given the least plus points or the most minus points? Yeah. What are their first names? Is there any relationship between the first name of the child and whether they're naughty children or nice children? So there you have the names of the nicest girls. Chloe, Emily, Sophie, my daughter's called Sophie, Jessica, Megan, Lucy. Nicest boys, Jack, Daniel, Joshua. Naughtiest boys, this is so unfair, Adam, Joseph, Charlie. Do you think that they've gone a step too far there? I think they might have gone a step too far there. Be careful what happens to this data, yeah? If you're going to use something like School Stickers or Class Dojo, ask questions about, are all of your stuff, DBS cleared, yeah? If your pupil's personal identifiable information is going into somebody else's database, be sure that that's being kept safely. Talking of information going into other people's databases, you have to fill in the census returns. You have to tell the DFE about how well your pupils are doing. That includes personal questions about special educational needs. That includes their exam results. That used to include the full returns from the early years foundation stage profile. Is the child able to dress themselves by the age of 5? Was a question which our government asked, and schools had to return that data from. Now that allows central government to do all sorts of interesting things, like figure out the relationship between the type of school and how well pupils do. That allows us to look at the big trends across the whole system. But interestingly, our Department for Education decided to make a lot of this data available to carefully selected third-party organisations. Not at personal level, well, not at individual name level, but that sort of level of individual responses to these questions was something which other organisations could come and ask for. One of those other organisations was the Home Office. And the DFE released the data on 2,500 children because the Home Office asked for that. I don't know. I don't feel that was the reason why the data was collected in the first place. Is, should this child be deported? Should this child's parents be deported? That's not really what schools are about. But DFE, yeah, here, have a go. The flip side of that is it allows us to make good decisions. Epidemiology, again, coming back to the case in point, has saved so many lives because we know what works in medicine. And the argument for tracking all of this data on individual children is exactly the same, so that we know what works in education. If you insist that everybody gives full, detailed, informed consent, your parents, your pupils, have not given informed consent to their data going to the DFE. If you insist on the informed consent, people opt out of that, as would be their right. And so you don't get to see this big national trend. And epidemiology is much harder if you don't have that trend data. So there are pros and cons to this. Where do we get to with that? That's something you should be talking about, I think, up in your philosophy, ethics, RE, PHSE lessons with your 15, 16-year-olds about what, is it okay for this data to be shared? What are the advantages? What are the disadvantages? Privacy probably is a good thing. But there are occasions when we choose not to worry too much about our privacy. Google knows everything I search for. Facebook knows all that I do. Strava knows where I go running, yeah? I choose to make that decision. There are occasions when we feel we get a benefit from that. Right, okay, so Sarah said I was supposed to do questions, but she also said I should have finished 10 minutes ago, which is really difficult to do both of those. The slides are all online, and most of those are linked through to supporting documents. Can I do one question, two questions?
We probably have no time for one question, but yeah, let's take questions. Somebody, anybody.